I have a question for you. Is a light switch a computer? Your initial reaction would probably be to say no. It's just a tool to create light. But it has an input and a wired connection, and it creates light based on what you input. But isn't that kind of meaningless and semantic? What actually makes a computer? It's kind of a fuzzy concept to me, and yes, it has a dictionary definition, and I'd recognize a computer when I see one if it was put in front of me. There are a lot of edge cases, you know? Is a slide rule a computer? Is an abacus a computer? Is a bunch of stones you move around a computer? I propose we do a little digging into the history of computers to figure this out. And by propose, I mean that's what I'm doing. It's my channel, and you can't stop me. While we have our impending machine overlords and the living internet before that, and ARPANET before that, and the Turing machine before that, and weaving machines before that, and the Greek machine before that, we have to start somewhere. And a good place is with the origin of the English word. Computer did not always mean a machine. Computer used to be a job. It was something a person did, that is to say, computing. That is to say, someone who performs mathematical calculations. The term first started being used in the early 1600s, describing assistants to astronomers and mathematicians who would employ them as sort of grunt work assistants, who, from what we could tell, were primarily used to crunch numbers so that the researchers could use their time more efficiently, interpreting data and concerning themselves with theory rather than just chewing through numbers all day. This definition of computer would stick well into the 20th century, but already machines were being made that resembled the computers of later years. Blaise Pascal, oh hey, it's that guy from the other video I made, created Pascalines starting in 1642, essentially mechanical calculators to help him with his math work. Not long after, a young Gottfried Wilhelm Leibniz would develop the concept of binary, and then make his own arithmetic machine in 1671. But the concept of computation being simple math machines wouldn't last long. In the 1700s, another step would be taken. The precursor to modern machine computing was developed. A loom that could take instructions in the form of punch cards. The important part here isn't the loom itself. The machine could have been for any task. No, the important part in the history of the computer is the punch card, a customizable input that can be used to direct the machine in various ways. But while these punch cards were detailed and, importantly, repeatable instructions, they had another step before they would start to properly resemble the programming of today. For that, we need the enchantress of number. In the 1820s, Charles Babbage made the difference engine, another mathematical machine, one more advanced that could do logarithms and trigonometry. Why those things? In a word, engineering. In the following decade, Ada Lovelace saw Babbage's work and was spellbound, with the two becoming colleagues and lifelong friends, where he would nickname her the Enchantress of Number. A few years later, in 1837, Babbage would propose a more advanced version of the engine, which would unfortunately never be built. Ada wrote up tables of mathematical algorithms for this machine to use, widely considered the first computer program. The dividing line between punch cards and computer code proper is a matter of philosophical debate, a debate which I am not going to chime in on here. Come the 20th century, scientists and manufacturers had increasing need of machines capable of processing and managing data, and the loom concept was pushed forward, with physical mechanisms being replaced by electricity, and the punch cards being replaced by machine code, which has a history all its own, but in its simplest possible explanation, is essentially instructions for sending pulses of electricity to make the big network of wires and resistors do things. And then the Z4, the first commercial computer, was released in 1945. Like, that is just insane to me. Anyway, enter stage left, Alan Turing. While his best-known achievement is the creation of the bomb machine in World War II to crack the German Enigma machine, his most significant contributions to computing came after the war. He designed a computer with vastly improved memory capabilities and was instrumental in the development of philosophical concepts that inform how we think about computers, like mathematical models of computation and Turing tests for the imitation of complex behavior. Machine code gets more advanced, we develop better ways to tell computers how to do things, and hey Macarena, we've got computer coding languages. Then in the 1960s, the US Air Force was looking for ways to make a more secure area network for radar defense, and incorporated a decentralized network. Not long after that, ARPANET, the first wide-scale network of this kind, was implemented for the US Department of Defense, and became the precursor to the internet we know today. Modern breakthroughs and projects are ongoing, with hot topics like artificial intelligence and quantum computing and post-humanity where we all transform into Necrons, but the internet is by and large still the big man on campus, so we will leave it there for now. Now, there is a lot that I had to leave out, but those are the big strides, and I feel like we've gotten a pretty good handle on what a computer is. A computer is a device that takes information and processes it. The device itself handles the information, so all you need to do is provide it. Consider the loom again. Yes, you could arrange each of the arms and racks manually to perform the weaving that you like, but it's set up so that you don't have to do that. Instead of spending hours configuring machine parts, you spend minutes punching holes out of a card that you then give to the machine. A computer is at its core a labor-saving measure. Some basic computers are fixed, efficiently doing a single task they were made for. Others can be configured to save time on many tasks. Just like the original computers, paid laborers who crunched numbers, it's something the mathematicians could have done themselves, but decided their time was more valuable than the resources required to hire, or later build and run, computers. Remember, early aerospace calculations were done on chalkboards. Most of what computers do and have done can be handled by human labor. We've just decided not to. While the inner workings of most computers can be understood fairly well, there is an element of black boxness to computation. You could, in theory, understand each line of code in Doom and simulate the entire game with rows of pebbles, but why would you want to do that? Understanding computers is an important skill, but when it's running, the philosophy is, well, just let the machine do its job. It's thinking so we can do more important things. Let's get back to light switches. Are they computers now? Well, I think not. While it bears a superficial resemblance to computers, an input, wires, flashy lights, it can't process data. It's more of a medium than a device. But what about three-way light switches for when a light is controlled from more than one spot? Flip one switch up, the light turns on. Flip the other up, the light turns off again. The light is only on when one switch at a time is flipped up. That light has now become a logic gate, the foundational unit of all computers, specifically an exclusive OR gate. Chain together enough light switches, and you will eventually be able to perform math with them. Now, real computers use millions of logic gates that are nanometers across, made of semiconductors and not light switches, but it can be done. So, a light switch is not a computer, but through building up a very simple mechanism, we can build it up into something more. Whether it's light switches or vacuum tubes or semiconductors, a simple transmission device or materials with unique properties can evolve into an information processor. But now, this begs the question. If simple devices can become capable of processing information, when do processors become conscious? One of the better known and creepier examples comes from computer scientist Tom Murphy, a computer scientist who created a program to play NES games by simulating button input with performance gauged on in-game score. The most notable of these games was Tetris, which, when it was on the verge of losing, rather than taking the loss and accepting a final score, simply paused itself forever. I guess the only winning move really is just to not play. Was this an act of self-preservation? Was this bot afraid? Well, probably not. Bots made to play relatively simple games are easy to understand and make for an experienced programmer, and simple setups can lead to surprisingly complex patterns of behavior we call emergence. The YouTuber CodeBullet makes a lot of videos playing around with this topic that Murphy uses. Seriously, go watch him, he's absolutely fantastic. Add on our tendency to anthropomorphize, to see human-like traits even when these traits aren't really there. Most of the time, programs that appear to act human-like are simply not. A more pertinent comparison is not to look at how machines can act like humans, but how humans can act like machines. It's easy to dismiss these games as non-conscious because they work on fairly straightforward incentive systems, but isn't that kind of what we do? Our minds mostly operate on an incentive reward system based on the release of dopamine and serotonin, and the biology our conscious brains are built out of is fundamentally centered around getting more organic molecules to facilitate cell growth. We must admit that here is where we start to reach the limits of what we can say for sure. There's no timeline of things that are definitely, absolutely, provably artificially intelligent for us to look back on and define things by, as we rapidly enter the realm of philosophy and fuzzy definitions. Anemones and relatives do not have brains. They have nerve nets spread throughout their bodies and are generally thought to not feel pain. But if you've ever seen an anemone gallop away from danger, it's hard to imagine there isn't at least a spark of true thought in there. You could say we're anthropomorphizing this very simple organism, and you're probably right. But what if sentience is just that? Our simple brains projecting something more elaborate, more noble, onto other simple brains and thinking it something more. We are very good at pattern recognition, even when there is no pattern to be seen. If we can see human faces in places there shouldn't be, what if we see complex thought in places where there isn't as well? In animals, in computer programs, in other people, and even in ourselves. So, do we possess wisdom? Are we self-determined, or are we simply products of our environment? As easy to operate as a light switch? I would like to hear your opinion down below, so if you have thoughts, please leave them below, and consider subscribing if you have the free will to do so. Only time will tell.